In this case, we're told this is a Hess's law problem, but we can recognize a Hess's law problem when we're given some form of a target equation and two or more thermochemical equations. So the idea is, here's our target equation. We want to find some way to combine these two equations in order to yield this net equation. Okay, so we've written the value of delta H here. We put the value with the appropriate sign inside the parentheses, and we've had to multiply this by 1 since essentially we haven't changed this equation at all. It appears exactly the same as it does up here. The next thing I want to focus on is the SO2. In our target equation, the SO2, 2 moles of SO2 appear on the reactant side, and 2 moles of SO2 are on the reactant side in this given equation. So we're going to add in this given equation. Alright, so now what we're going to do is to add these two equations together and see where we are. When we add these together to get to our net equation, those things that are on the reactant side stay there, and those things that are on the product side stay on the product side. So we just sum all these things together. Looking at this, we see that 2 moles of sulfur are produced in one reaction, consumed in the other. So that will not appear in our overall net reaction. Okay, and here we are now. We can combine these oxygens here. 3 oxygens on the reagent side, 2 on the product side. So we're going to cancel out these 2 oxygen molecules on the product side, and it will cancel out 2 out of these 3 oxygen atoms. Alright, here we are, we're done. Our target equation matches our net equation here. And to find delta H of the net reaction, we add the heat associated with each of these reactions that we sum together. So in this case, it's just a sum of these two, and the answer is as written.